So this problem says a function is said to have a horizontal asymptote if either the limit at infinity exists or the limit at negative infinity exists. Show that the following function has a horizontal asymptote by calculating the following limit. So we're trying to find the limit as x approaches negative infinity. What we can do to evaluate this is to find the highest degree of any term in our polynomial fraction. The highest degree would be x to the power of 3. So let's divide every term in our fraction by x to the power of 3. That makes the limit as x approaches negative infinity. It would be 5x divided by x to the power of 3 minus 8 divided by x to the power of 3 over x to the power of 3 over x to the power of 3 plus 13x divided by x to the power of 3 minus 15 divided by x to the power of 3. Okay, so now let's do a little simplifying. We can make this the limit as x approaches negative infinity. The x and the x over 3 would cancel out to make 5 over x to the power of 2. This doesn't have anything that'll cancel, so it would be 8 over x to the power of 3 divided by the x to the power of 3 over x to the power of 3 makes 1 plus 13x over x to the power of 3 would be 13 over x squared minus 15 over x cubed. So now, if we were to plug in negative infinity for each one of our values of x, every fraction that has an x in the denominator would go to 0. So this fraction would go to 0, this fraction goes to 0, this fraction goes to 0, and this fraction goes to 0. So what we're left with, the entire numerator goes to 0, the denominator goes to 1. So since we have 0 divided by anything other than 0, that gives us that our limit would equal 0. If it was 0 divided by 0, then we couldn't use this strategy and we would have to look for a different strategy. But because it's 0 divided by anything other than 0, we can say that the limit is equal to 0. That also means, since we were talking about how that a function has a horizontal asymptote if the limit exists, that means that the function also has a horizontal asymptote at y is equal to 0. So I hope this video was helpful for you. If it was, please subscribe to my channel for more homework help videos, and feel free to leave a comment with any problem that you have, and I'll see what I can do to get to it. Thanks.